What's going on, everyone? Welcome to this series of videos about the general principles of manufacturing process. And today we're going to talk about the push versus the pull system. The push system is production based on schedule and forecast of the customer demand. So the operation schedule when they are supposed to run the job, and they forecast what's the customer demand. So they actually produce parts based on the forecast, how much the customer expecting to order parts. While the pull system, it's a production based on the actual customer demand. And the Kanban system is actually one of the tools used to implement the pull system. We're going to use a Flexsim model to show the difference between the push system and the pull system. So let's go to Flexsim. So this model is running based on the push system principle. And it's very simple. We have raw parts comes from the left side, and we have a machine running the parts. The parts will be packed in a skid, and then I have a high-low going to start loading parts, moving parts from the operation to the storage, to the warehouse. And then once a day, we have a truck comes in to pick up parts from the warehouse and ship it to customer. So the customer demand changes. Going to speed up the simulation so we can see when we're going to start building inventory. So as you can see here, this is finished goods. This is in the warehouse, and all is going to be stored in the warehouse. And the next day, we're going to have the truck comes in. This truck is not moving, but it's actually this will move, which means that we start shipping. So the issues we have in the push system is too much inventory, because we're forecasting how much we think the customer will order. And that's why the operation team will just gonna keep making parts and building inventory. And the inventory is gonna require more investment of the raw materials, a raw investment from getting space to store all these. So if I see the chart of the inventory versus time, I'm gonna keep running this simulation. So this is how much inventory in the storage area in the current, and it's actually go up and down. So it goes down when the truck comes in to pick up the finished goods. So here is in the peak. Here means I had too much inventory that the operation cannot make any more parts because there is no space to store those parts. So they stop until the truck comes in next day to pick up parts from the storage area to ship it to customer, and then we start building inventory. We have to remember this number, 250 skids. We're going to need worth of space in order to run this simulation. So now we go to the pull system simulation. In the pull system, a few things we have to do first. First, we have to know how many Kanban cards we're going to need. Each Kanban means one skid. So the Kanban cards, number of Kanban cards, it depends on the customer demand multiplied by the lead time divided by how many parts we have in the container or in the skid. The customer demand we have is around 540 all the way go to maximum of 720 parts per day. The lead time is 1 day. Just to put this in the formula, we have 120. So this means 120 Kanban cards we can put to the system. This is a picture of the skid packed with 6 parts, and we can actually apply the Kanban card when we finish packing. Apply this card on the skid. When this gets shipped, we take the Kanban card and we take it back to the system. So this is like a Kanban card, and the Kanban board have 120. So we're gonna plug this in the push system that we made, and we actually turn that to the pull system instead, and we're gonna see the difference. We have this is the Kanban boards. This is the Kanban card. So let's run this quickly so we can see the inventory again. Start building inventory. All right. So the way it works, because it's happening too fast in the simulation, this is the Kanban board. So when 6 parts has been made and packed, so I have full skid here, this operator will pick up one card and apply it on the skid and will look like this. So this is the Kanban card. So each skid, before it's shipped to the customer, the operator will pick up this Kanban card and move it back to the Kanban board. This operator is going to keep making parts until the whole board becomes empty or there's no more cards in the board. So they stop because means they build up enough inventory that they don't need any more. That actually meets the customer demand. And that way they can avoid keep building up too much inventory. So we're going to run the simulation faster. And I have this operator is actually moving the parts from the finished good. That's actually, they take it from here. This is the Kanban cards and move it back to the board. So what we have here, the board, the Kanban board is empty, which means that we actually reach to the maximum lot size we supposed to build in the storage area. So the operation team is not going to make more parts, basically. They're going to just wait until the customer start pulling parts from the storage area. And then we're going to have Kanban cards here, and then the operation will proceed again. In the inventory versus time, you actually can see the how much inventory we have versus time. If I keep doing faster, so by the end of each day, this is how much inventory I have in the warehouse. And it's not exceeding more than 120. So this is the push system. And you can tell it required 250 skids of inventory based on the simulation we run. The pull system is going to require around 120 skids inventory. And both of them is actually running on the same customer demand. That's all I have for today. Thank you for watching, and I talk to you later.